Here's an example that has a tangent in it. Here they gave us the domain, so we don't have to really think about that. We do a little bit have to think about it, though. It's only a second to think about it. Right there, asking for the graph from minus pi over 2 to pi over 2. As we know, tangent, right, it's sine over cosine. So it's going to have asymptotes at minus pi over 2 and pi over 2, right? So we can tell that we're going to have vertical asymptotes at x equals plus or minus pi over 2. It might be worth looking at which direction it's going, just because that's going to help us graph it. But of course, knowing the sign, well, knowing whether it's increasing or decreasing will also help us graph it. So that's fine. Maybe we don't want to waste our time with that. Now, what about intercepts? We can see that if I let x equal 0, obviously tangent of 0 is 0. So f of 0 is 0. I have that. There may be more intercepts, all right? There may be more x-intercepts, but that becomes a little bit of a problem. This is not easy to solve, right? Because there's not a good way of doing this, okay? This is actually what's called a transcendental equation. Because you've got x here and tangent x here, there's not an easy way to solve for that. So I'm not going to bother, okay? I'm going to say, yeah, there might be some more, but we can't find them easily. In fact, to solve this for the roots of this equation, you may have to use a numerical method, such as Newton's method, which is later in this chapter, or a graphical method. Well, we don't really care that much. It's not going to help us. If we can't get the intercepts easily, yeah, we're just going to not worry about them too much. Okay, so next we're going to go for our intervals of increase and decrease, and the maxes and mins. So if I take the derivative of tangent is secant squared, right? So this would be 2 minus 1 over cosine squared x, right? And so I want to find out where this is equal to 0. And of course, where it isn't defined, but we already know those pi over 2 minus pi over 2. That is part of my thing here, right? So I have cosine squared 2 cosine squared x minus 1 equals 0. Cosine squared x equals 1/2. Cosine x is equal to plus or minus 1 over square root of 2. Right? We know what that is. That's root 2 over 2. That's going to give me x equal pi over 4 and negative pi over 4. Okay? So, let me write up my thing here. So I've got minus pi over 2 to pi over 2, and I've got 2 points that I found, minus pi over 4 and pi over 4. Now, if I'm looking at this guy, right? So I'm going to try some points and see what the sign is. Of course, if I try x equals 0, right? This would be 1, 1, 2 minus 1, 1. This is positive in here. If I try something between pi over 4 and pi over 2, okay, so it's pi over 3, right? So pi over 3 would be here. Cosine of pi over 3 is going to be 1/2, right? So this would be 2 times 1/4, so 1/2 minus 1, that's going to be negative. And the same thing's going to happen over here, right? Because it's cosine squared, so it would still be 1/4. So I can see this looks like I've got a minimum there and a maximum there. So my intervals of increase and decrease, I'm increasing between minus pi over 4 and pi over 4, and decreasing minus pi over 2 to minus pi over 4, and pi over 4 to pi over 2. Okay? Now my maximum, looks like the maximum is happening at pi over 4. So let's see what the value is there at pi over 4. F of pi over 4 is 2 times pi over 4 minus tangent of pi over 4 is 1, right? So pi over 2 minus 1 is my coordinate there. So it's like pi over 2 is like 1.7-ish. So pi, that's something like 0.7, right? And this also sort of like 0.7-ish. We can be not so exact there. And then for our minimum, it's going to happen at negative pi over 4. So f of negative pi over 4 is going to be negative 2 times pi over 4. Now, the tangent here is going to be negative 1, right? So this is going to be 1 minus pi over 2. Okay. So that gives me my coordinates of my maximums and my minimum. Maximum and minimum. So I'll just go from here. Now I want to do the concavity. Let me see. So taking the second derivative, I have minus 2 secant x times the derivative of secant is secant tangent. All right, so what does this look like? So secant, this is 1 over cosine squared times sine over cosine. So in terms of sine and cosine, and I'm just writing it that way because for me it's easier to solve for the points when it's in sine and cosine than when it's in secants and tangents. So that's just a personal choice. So let's see. So this is going to be, again, this bottom is going to be, oops, cubed. Careful. That will make a difference in the sign, so I have to be careful. Okay, so the bottom, of course, is the minus pi over 2 and pi over 2. The top is going to be 0 at 0, right? So if I do my second derivative, I have this business. Now let's put in some points. If I'm between 0 and pi over 2, sine x is positive and cosine x is positive, but this is negative, so it's going to be negative. If I'm between minus pi over 2 and 0, I can think about that as being in the fourth quadrant. So cosine is positive, but sine is negative. So this would be plus. And okay, so that looks like it's making some sense. All right, it's consistent with what's above. All right, so we have concave up from minus pi over 2 to 0, and concave down from 0 to pi over 2. And our point of inflection is at 0, and we know that it's 0, 0, because we already found that point. All right, so let's put all this together. Oh, I didn't want to erase that. Into a graph. Here, let's do this as pi over 2, This is minus pi over 2. So this would be minus pi over 4. This would be pi over 4. This is going to be 0. So we have these two asymptotes. And so let's double check thinking about this if this makes sense. If I'm going towards pi over 2, and I'm going this way, this is something positive, but it's minus the tangent, and the tangent is going to be something positive. So this should be negative. This should be going down negative. That makes sense because my function's decreasing. If I'm over here, so this is, I said we didn't really have to do the limits, but if we do, it just gives us more of a feeling. So x going to pi over 2 from the left of f of x becomes 2 pi over 2 minus something is going to infinity. So this goes to negative infinity. And if I'm going to the other side, pi over 2, minus pi over 2 to the right, again, this is going to be minus 2 pi over 2. So that's not going to make a difference because it's just a number. But then this is going to be going plus infinity. Okay, so this is going to go up there. And that also makes sense because if I think about what's going on, all right, let's see. Now let's put in our numbers. Pi over 2 minus 1 is going to be, here, I can find exactly which one it is. Here. Pi over, oops, that's not right. Pi over 2, 1.57, right? I thought it was 1.7, it's 1.57. So this is pi over 2 minus 1 is going to be like 0.57. And of course, 1 minus pi over 2 is going to be negative 0.57, right? And if I look at, just to get the right kind of shape here, if I do pi over 4, pi over 4 is like 0.78. So I'm not going to go quite up as far, maybe like here, and maybe like here, right? So just sort of putting these together. Like that. So that is our graph. The tangent's kind of like the tangent function, right? But the 2x has given it these maximum and minima. They only asked you to graph it from minus pi over 2 to pi over 2. In fact, it looks similar on the other ones, but this is not a periodic function anymore because of this 2x. So if you do go to Desmos and graph this, you'll see the same shape, but it moves up and up and up, or this moves down, down, down. Because the numbers, it's still going to be the same points, right? It's still going to be pi over 4 from the center point, but this is going to change the x, y coordinate. Okay, so that's sensible. And it works with both of these, right? I'm decreasing, increasing, decreasing, concave up, and then concave down.